In this video, I'll be comparing the OpenSPOT2 with a generic Chinese-made hotspot using the Pi-Star software. These are both devices that perform the same function. They allow you to talk to other people on your radio over the internet, which is great if you're not in the coverage of any repeaters in the mode you want to use. Both devices work with the same digital voice modes, and those are P25, D-Star, DMR, NXDN and Yaesu System Fusion. I chose to compare these two hotspots because they seem to be the most popular choices right now. They also both support linking between different modes, so if you have a DMR radio for example and want to talk on Fusion, then you can. Let's get into the comparison between these two. I've got a few categories and I'll go through each individually. The first is battery life or energy usage. Neither of these devices have batteries built in, but they can both be used with USB power supplies like this one. This is quite a large one because I use it for other things like charging my phone and wanted a large capacity, but you can get much smaller ones which will power these hotspots just fine. The only difference will be that they won't last as long. One of the selling points of the OpenSPOT2 is that it has very low power consumption. I don't have the appropriate equipment to test this, but I recently saw a video by another channel which showed that the OpenSPOT2 does consume slightly less power than a hotspot based on a Raspberry Pi Zero W, like this one. The theory behind why the OpenSPOT2 has lower power usage is that its hardware and software are designed purely for use as a hotspot, whereas the Pi-Star based hotspots are actually little computers running Linux, and so have to run all the other bits that come along with it. The Pi-Star based hotspot runs Linux on a Raspberry Pi. This specific model uses the Pi Zero W, which has built-in Wi-Fi, but you can also use the larger Raspberry Pis which have more USB ports and an Ethernet connection too. The software is freely available to download online, but note that you can't just put the software on a Raspberry Pi and expect it to work. You need an extra board which handles the radio side of things. That's what this antenna is connected to. You can buy these boards separately if you already have a Raspberry Pi. The Pi-Star software is open source, which means the code is freely available for anyone to view and make changes to. This is a good thing because it means that if some people don't like the way the project is going, or want to add features that the original developers don't have the time to work on, then they can make their own copy of the software and change whatever they like. On the other hand, open source software often doesn't have the kind of support and continued development that commercial software has. Since open source software doesn't earn the authors any money, it's treated as a hobby, and development often dies away as the authors lose interest. Sometimes new people take on development of open source software, but it can never be guaranteed, especially with smaller projects. Commercial software, which in the case of the OpenSPOT2 is being paid for when you buy the device, tends to have better support and continued development, because people are earning money from it and therefore treat it like a job. However, you do have to keep in mind that commercial software is there to earn the author's money, so after a while it often gets replaced with a new version, which has to be paid for again. This is relevant here because the original OpenSPOT is no longer being updated, and people are expected to buy the OpenSPOT2 if they want updates. Eventually the same thing will probably happen with the OpenSPOT2, and you'll have to buy the new version if you want updates. The OpenSPOT2 has a very nice update mechanism where it automatically checks for updates and installs them for you. It even reboots itself to apply the update at a set time each day. This seems like it was designed for you to just leave the device on all the time, but would also work fine if you just turn it on when you want to use it. The Pi-Star updates have to be checked for manually, but thankfully it does handle the rest of the procedure for you. You just have to make sure to go and check for an update every so often. Both devices are quite easy to set up. With the Pi-Star based hotspot, you can buy the hotspot already assembled with the software already loaded correctly onto a micro SD card. From that point you have to connect it to power and then just connect to the Wi-Fi network made by the hotspot to enter your Wi-Fi details. This can be your home Wi-Fi, public Wi-Fi, or you can even use a smartphone to create a Wi-Fi access point and share its cellular data connection. The OpenSPOT2 works very similarly. When you connect it to power for the first time, it will make its own Wi-Fi network, which you connect to and then enter your Wi-Fi details. I would say that the OpenSPOT2 is just a bit easier though, because it immediately presents you with the setup screen when you connect to it. Whereas with the Pi-Star ones, you have to go into the configuration and find the Wi-Fi settings yourself. The OpenSPOT is also easier to log on to once you have it on your Wi-Fi. There's a website called sharkrf.link which you can use to automatically get the IP address of the OpenSPOT and connect to it. The Pi-Star devices don't have an equivalent service, so you have to use its DNS name, but this doesn't work on all devices, such as Android phones. In that case, you have to find the IP address in another way. The user interface on the OpenSPOT is easier to use, in my opinion. When you want to connect to a radio network, it first gets you to select the mode your radio is in. Then it gets you to choose the network you want to use. It doesn't mention anything about cross-mode linking, even if you are connecting to a different mode from the one your radio is using. On the Pi-Star hotspot, you have to first enable the mode your radio uses, then save it and wait for it to apply. Then you can put in the settings for it. If you want to use a different mode from the one your radio has, then you have to go and enable the appropriate cross-mode toggle, wait for it to apply again, which takes about 30 seconds, and then you can adjust the settings for the mode you're linking to. This is much more complicated and time-consuming than with the OpenSPOT. One thing I prefer about the Pi-Star hotspot is that it keeps the latest radio activity all the time in the dashboard. So if you go to the web page, then it will show you who spoke even before you logged on. With the OpenSPOT2, it only shows who talked after you open up the web page. I've wanted to check the call sign of someone who just spoke before and haven't been able to see it with the OpenSPOT since I didn't have the web page left open. The OpenSPOT has a voice announcement feature that's missing from the Pi-Star hotspots. It announces when the device connects, what it's connected to, and if it's having trouble connecting, so you know what's going on. This can be quite handy if you're using it mobile and don't want to use a computer or phone to check on the status of the hotspot. On the other hand, the Pi-Star hotspot has a display which shows you the call sign and other details of the person transmitting. It also shows which mode is being relayed. You can access all this information on the dashboard of both of these hotspots anyway, but it is handy to have it shown on the display. The OpenSPOT wins by far in this category. It starts up very quickly and begins relaying the mode it was set to when it was last on. The Pi-Star hotspot takes a while to start up, like any computer, because it's running an entire operating system. This is to be expected, and it shows the advantage of the embedded software that the OpenSPOT2 uses. I wouldn't say that either hotspot has a huge advantage with durability. I like the metal case on this hotspot, and I think it would stand up pretty well to being dropped, but then the antenna sticks out and is liable to getting snapped off. The OpenSPOT2 feels a bit plasticky, but it's very light, so would also probably handle a drop, and it has a built-in antenna, so there's nothing sticking out to snap off. On my previous video about the OpenSPOT2, someone commented asking if the range of the OpenSPOT2 was really bad since it doesn't have an antenna. Well, actually it does have an antenna built in to the unit. I haven't tested the extremes of the range of this unit, but it works perfectly adequately for use around the house. At the usual distances you'd expect to use a hotspot, there are no issues at all. In fact, I think the built-in antenna could even be an advantage, because it will be made specifically for the frequencies the OpenSPOT2 is designed to work on. This antenna probably isn't going to be all that well tuned for the frequencies this hotspot is designed to work on, but you could replace it with a larger antenna, and in that case you probably would get better range than the OpenSPOT2. Overall though, range isn't a huge concern, as hotspots are only intended to be used over a short distance. The radio boards used in the cheap Chinese-made Pi-Star hotspots are not always the best quality. You can get better quality versions, which you pay more for, but I don't have any experience with these. I have found that you do need to calibrate the frequency manually to get the best performance. The frequency the hotspot receives on was not quite right, so I had to transmit, check the bit error rate each time, and then adjust the RX frequency offset by a small amount until I reached the minimum bit error rate. Bit error rate means the number of errors in the digital data from your radio. If the frequency on your hotspot is not perfectly aligned with your radio, then you'll get more bit errors, which will cause you to have worse audio quality. With the OpenSPOT2, I didn't need to calibrate it at all, but I did, just so I could see how easy or difficult it is, and I found that it's incredibly easy. You select the AutoCal connector, tell it which mode your radio is using, and then just hold the push to talk button until it tells you to stop. It automatically adjusts the frequency offset for you and saves it. Considering that both of these hotspots have pretty much the same function, the Pi-Star hotspot is far better value for money. At the time of making this video, you can buy them for around $80 shipped, whereas the OpenSPOT2 is being sold for 225 euros shipped. I wouldn't normally include the shipping cost when comparing products, but because the only way to get the OpenSPOT2 is direct from SharkRF, and they don't offer any alternative shipping methods, it's pretty much built into the cost of getting this device. The OpenSPOT2 undoubtedly works much faster, is easier to use, and is overall just a much more polished product, which is what you'd expect when it's a single system with all parts made by one company. I highly recommend it if that's what you're looking for and you have the money to spend. But if you're looking for the best value for money, then you'd be better off going with one of these. I want to say thank you to SharkRF for giving me the opportunity to review this OpenSPOT2, and thank you for watching. Please click like if you enjoyed this video, let me know your thoughts down in the comments, and if you're not subscribed already, then you may want to consider it.